Today we'll be talking about triangles. A triangle is a linear figure formed by joining three non-collinear points. And yes, two of them may be linear, but the third one is never linear with both of the other ones at the same time. So, for example, when you have your points here, these 2 points right here and here are linear, but this one in that group is not linear with both of those. It's not on that same line. So that's what they mean by non-collinear points. Let's look at all the types of triangles. First type of triangle is an equilateral triangle. So as it says in its name, equal, you have 3 congruent sides, and the way you indicate that is by putting the same amount of tick marks on each side. So if I have 1 here and I want to say this is equal, I put 1 there as well. So they have 3 congruent sides. An isosceles triangle needs to have at least 2 congruent sides. Could it have 3? Yes. So you could have an isosceles equilateral, or you could just have an isosceles. So if it has 3, it would be considered an isosceles equilateral. And then there's the scalene triangle, which has no congruent sides and hence no tick marks on anything. Let's look at the angles according to each triangle. So there are triangles that have 3 acute angles. So in here you have 3 angles that are less than 90 degrees. You would call that an acute triangle. An equal angular triangle has equal angles on all sides. And an equal angular triangle is also acute because if you divide that 180 by 3, you're going to get 60 degrees on this whole thing. So therefore that's less than 90 degrees, which is acute. And a right triangle has a right angle. An obtuse triangle has only one obtuse angle because you can't have more than one. It wouldn't make it a triangle anymore. So those are the types, depending on the sides and the angles. Let's look at how you identify parts of the triangle. So a vertex in a triangle is going to be each of the 3 points that join the sides. So point C is a vertex, point B is a vertex, and point A is a vertex. If you have more than one vertex, you say vertices. So 1 is a vertex, 3, 2 are vertices. Adjacent sides in a triangle are 2 sides sharing a vertex. So I could say that line BC and AC are adjacent sides with one another if I wanted to. I could say that BC and BA are adjacent sides because they're sharing that vertex. Now let's look at right triangles and isosceles triangles. And we're just labeling the parts. On a right angle, the legs, these, are the sides that form that right angle. So they come together to make that right angle. Opposite from that right angle is the hypotenuse. Hypotenuse is always the largest part of the right triangle. And on an isosceles, we have 2 legs and a base. And so the legs are the 2 up here and the base is at the bottom. Interior and exterior angles. Interior angles are all the angles on the inside of the triangle. Exterior angles are adjacent to interior angles. So that means here's your interior, here's your exterior. Here's your interior, here's your exterior. You could also consider this guy as well. So those are exterior. Now let's look at some theorems. We have the triangle sum theorem, and basically you're just adding up all the angles in the triangle. So you have this, this, and this, and it should equal 180 degrees in a triangle. So the sum of the measures of angle A, B, and C equal 180. If you get posed a problem where you need to find a missing angle or a missing variable, you add up all your angles inside and set them equal to 180 and solve. The exterior angle theorem states that the measurements of B and A should be equal to that exterior angle alongside the adjacent to interior angle C. So right here. So B and A should be equal when you add them up to angle 1 on the outside. So let's see how we could use that. So if I was posed, if I were posed a problem like this, and I had this missing x variable and I had an x variable here, from that theorem before, I know that 65 plus x should equal that exterior angle right here. So I set up my theorem, and then I plugged in my values. So I have my 2x, which is right here, plus 10, that's my exterior, should be equal to that angle x and that angle 65 when added together. So I solved my equation and I got x equals 55 for that. But if they asked for the actual degrees, I would plug in that 55 and find out the degrees. And you could check it that way as well. The last thing we'll talk about is the corollary to the triangle sum theorem. The acute angles of right triangles are complementary. So that means you know this is 90 degrees and a triangle has to have 180. So therefore this angle plus this angle must equal 90 to give you that 180. So you might be able to apply that in a problem where you have the two variables, or you have a variable and another variable, and you need to solve for those. You know this is 90 degrees. You could add all these up and equal it to 180, but it's kind of shorter just to do the 2x plus x equals 90. And then I solve and I get x equals 30. You're going to apply these on Monday, so get ready, and then we're going to talk about proofs with triangles.